Okay, data exploration. We're continuing with the California data set. It's a standard data set used in most of the common, like GitHub and places like that. So you'll see it in a second. Same procedures. Import your code libraries and mount your drive. Then we've got inputting the California data set, which is, let's see here, California housing. That's why I have it listed. I just did this here to make sure that California housing was not SLXX. If it were, usually you'll have to import XLRD. Again, let me just say, get some interesting questions that GPT should be answering. Let me get down a little bit further and I'll show you what I'm talking about. If you run into a problem, you got this pretty well straight. You could ask GPT or Claude or whatever, Gemini, if you have any confusion about code libraries, just understand they're there for functionality. And it'll tell you if you get down deep in your code and you've forgotten to load one in, it'll give you the error, then you'll click on Gemini or whatever, and it'll say, load this in. So this is pretty standard stuff up here. NumPy handles numbers, Pandas handles organization, missing numbers. This is for plots. And then Seaborn, same thing. Import OS is only used in some vague cases, but this is not the important stuff, okay? You'll end up probably coming up with a master list that you want to input as we go through these notebooks, that you'll just load them up in the first sequence. The good news is, once they're there, you're fine. But Gemini knows all about these things, so does GPT. The imputers, we're going to use that, of course, to impute and then to scale. So we'll get there. Mount the drive, load your data set. Y'all, the questions I'm getting, you're there, no problem. This one has, it's a small little data set, 20,000 instances, 10 features. Okay, so what they've done, they came up with this. This is real California data from back in the day. So what do you have? Latitude, longitude, like we talked about, median age, total rooms, total bedrooms, population, households, median income, median house value, ocean proximity. It's really cool because it looks simple. So you come down, you say, let's look for null values. By the way, what you're looking at here is a toolkit. I'm giving you all these extra instances like box plots and DF describe and checking for normality. Back into that if you want to. It is a toolkit. Don't do it first. Okay, clean this mess up before you start anything like the statistical procedures. You do not have to do everything I do in class. This is like you have a toolkit. You select the tools that you need. Now y'all are going to need different tools. You have different data sets. Okay, so I'm just giving you as many as I can think of in 3 weeks. Okay, so you're going to do nulls. You do not have to use bar charts. There it is right there. Everything's clean all the way across, no missing values. Where am I? 20,640 instances. Well, that's full bore. 2 of you have already turned in data sets to me to take a look at that have no missing values. Okay, so we've got a little bit missing here in total bedrooms. Then do the percentage of null values. So if I don't want to list it with a bar chart, there you go. Okay, percentages if you want, but there's the deal. Everything else is 0. You want to get this down where all features have no missing values. All right, so I got 207 missing in total bedrooms. So I come down, I start looking at these features. Float, 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 those are numeric. Integer, still going to be numeric. What am I looking at for categorical object? You can also say, well, that's pretty realistic, but you can look up here and see the same thing. Some of you have a lot of features, so this is going to be a little bit hairier, but right off the bat, this is like customer number over here, latitude and longitude. Dump it. You don't care what the customer number is, and we're not going to use latitude and longitude. You could, but that's more Python code that we're going to go into this semester. Out they go. Notice if you come across here, categorical clearly, and I have different orders of magnitude. And that does not play well with machine learning. We'll come back to that. So you come on down, doing great. Dump latitude and longitude. Here's the code for it. Here's the missing values. Well, we've already seen total bedrooms listed. There it is, 207. Just gives you a check. I want to impute now. I commented out all this code. And the reason was, this is just different examples of how to impute. So you've got these strategies. Set the imputation for your data frame, which is the same thing as a data set. And you say, okay, here's my strategy. Mean, median, most frequent, constant. Mean, median, mode, constant. Okay. So if you want to use constant, you're going to have a fill value, or you can use mean, median, most frequent. What's the one that is the least sensitive to large outliers?
Median.
Median. So I generally pick median. Now what's the interesting thing you can do? You have the code here for median. So let's go down here. All right, once again, we're going to have to do something with total bedrooms because we have those 207 missing values. Okay. All right. So here, you've got strategy of mean, then strategy of median, strategy of most frequent, and then those are the four. Then the constant was up here. I wouldn't use constant because I don't want to have to guess what a fill value is. I use mean here just for kicks. I don't recommend doing all four of them. Don't waste your time. Okay, just pick one. It's not going to affect what we're doing in here now. A data scientist might come in here and say, I've got 2 million values or 20 million instances, and so I want to see what happens with mean and median. That's not what we're doing. Okay, so you guys pick one. It goes down. So you've done the, I've imputed here with mean. So it says here now I've got number, name, and unique values in ocean proximity. When you have categorical variable, show up like this, could be male, female, could be education level, etc. You're going to get it picked up with object. You're going to come down. You know you've got to figure out how to handle it. By the way, you cannot use text. You got to, let's move that over to numbers. So I've got ocean proximity. That's my categorical variable. Now I need to figure out what the unique values are. This code gives you the unique values. All right, here they are. Let's see. Near bay, less than 1 hour from the ocean. Inland, near ocean, island. I don't know what lunatic came up with that, but it's in the California data set. This is not me doing this. Near the bay, near the ocean, well, you're in California, okay? On an island, we get that. Less than 1 hour from the ocean and inland, I have no idea what that means. I assume that means more than 1 hour from the ocean. Okay, the point is, there's no logical order in this. Okay, you can't say further and further and further and further and further away from the ocean. You can try, but then you've got an island sitting out here. Okay, so you got to figure out what to do with the island. So don't worry about that. Just one hot encode this thing. Or you could use direct assignment, but then you've got to figure out, do you want island as a 0 or a 4? You don't know which end to put it. You don't want it to be more important with 0, 1, 2, 3, 4, or less important. So one hot encode it. This will give it to you with, I'm still with a data frame. One hot encoded it, and this gives you that code. Notice the AS type integer. So what I do not want is true and false over here. It's no problem. If you forget this, it'll give you true and false. Just go back over here and make sure you've got AS type in their integer. So not anything major, but you can't work with true false. Okay, everybody's straight on this. Now, what do you get with one hot encoding? All right, now, the first 5 rows of, what am I doing? DF head. Notice every one of them is ocean proximity near the bay. I wanted to keep ocean proximity in there. You don't have to. And so I put columns equal ocean proximity, which is a prefix. The columns, this is what you want hot encoding. This is your prefix. To keep the prefix, just let you look at your features like color, card type, in this case, ocean proximity and so forth. Now, what's interesting about this is I've got this, but as soon as I encoded it, I had to add all those columns, all those features. Okay, so I've changed the data set, so I changed the data frame name. Okay, now most of the questions I've gotten so far over Labor Day, thank you very much, because you got fouled up with your data frame names. Okay, and you got deep in the code, and the data frame was original data frame, but you'd altered it. Okay, typically with encoding. So make sure that you're dealing with data frame. I just named it one hot encoding. If I put data frame here, DF head, I'd have gone back to my original data frame. Okay, everybody's straight. I'd have lost those extra features. Now, when you have something like this, you say, well, what do I have? I need to have 1, 2, 3, 4, 5. Great. So I've got it one hot encoded with 5. I had 1 previous feature, now I've got 5. One example, one of you sent in a one hot encoding where you ended up with over 100 features. That's the curse of dimensionality. Okay, you're going to overfit every time. We'll get back to overfitting, but overfitting means when your system, your code, memorizes the training data. Okay, so that you get, say, a predicted capability on training data of 0.98, then you run the test data and it's 0.62. Okay, it's memorized the features and their interrelationships in the training data so well, but it doesn't generalize the test data. That's overfitting. Again, we'll come back to that with metrics. Okay, so we've got this. And now you can look at it. We've dumped latitude and longitude. I've one hot encoded the categorical variable, so everything's numeric, but I'm way out of whack here with order of magnitudes. Check this with your data. Okay, with your data set. All right. Now, we've got to give some thought to multiclinearity. By the way, we've dumped missing values. We've imputed those. We've encoded. You're going to do this the same way every time, okay? Just do it this way for me. All right, so now I've got to figure out multiclinearity, which is correlations among the independent variables, okay, the features. All right, if you do this code, I've got the correlation matrix. Notice, do not go back to DF here. This is DF OHE because this is data frame encoded. Here's your correlation function. Here's you plot the figure, then you give it the figure size. You can adjust this figure if you don't like it by changing it. By the way, anytime you see green, those are what we call hyperparameters that you can change. Okay, it's not learned by the system. You change these. All right, so we go down here. All this code here gives you 2 decimal places, and then you've got the color palette. Okay, so I come down. I've got this boatload of things here. Obviously, your diagonal correlations are 1.0 naturally. Now, notice the numbers. If I have really intense colors and high correlations here, this means I've got very high positive correlations. As it gets paler, like this, and some of these, this one right here, then the correlations are lower. That's why it's called a heat map. Well, I've got a whole lot of negative correlations, but you have to look at this batch right here because it's extremely high. So what do I have? Total rooms, total bedrooms, and then you'd figure, of course, they're going to be very highly correlated, as they are, 0.93 and 0.87. Then I've got population and households. Well, these are census block. This is census block data, so typically you would have more households with a higher population. So you get very high correlations. Right off the bat, you guys have had high school statistics. You do not like that. Okay, so we're going to do something with this. Then I get down here, ocean proximity inland appears to be pretty highly negatively correlated with two of the other variables, as you'd figure, because they've got this kludged up. Well, I'm going to do something here. I'm going to think about this. So I come down. Okay, you've got some choices. Now, right off the top of your head, you should think to yourself, well, okay, I'm going to dump total bedrooms, or I'm going to dump total rooms, to get rid of that multicollinearity from those two features. You can do that. Population, households, you're kind of thinking, that's really high correlations. Population, household, 9297. Maybe I can drop one of those. The simplest thing to do is drop one. My recommendation would be look at it a little harder. Okay, so you've got this high correlation. So what we're going to do is going to create new ratio features. This is called feature engineering, where we're actually going to create new features. Now, you say, I have no idea how to do that. Okay, here's what you do. Back up here, and you're thinking to yourself, I need to figure out what to do right here. So what do I tell GPT? Up here, the DF, your data frame encoded head, and you copy in, you could copy the first couple of rows, just do this. You could do all 5, 3, 2, or 1, whatever. And you Control C and you Control V this right into GPT. Okay, here's my data set. If you wanted to, you could even give the original, but it'll understand what you're doing here. So this is current data set. Given that, I have multicollinearity here, and you can type in what's highly correlated or whatever and say, how would I fix that? It'll give you the options, drop one, or it'll say create new ratio features. It'll literally walk you through that. Okay? In other words, you don't have to know this, just ask it what to do. Matter of fact, you could just wing it. Say, I have a data set, I need to know how to handle multicollinearity. It'll give you these options. Drop one or create new features. Okay, once you've given it this, I guarantee you it'll come up with ratio features for you, or some sort of combinations of features to create. So what's it done here? Okay, instead of total bedrooms and total rooms, it says, let's create average rooms per household. Okay, that's total rooms divided by households. Then it created average bedrooms per household, same way by dividing total bedrooms by households. Average occupancy is population divided by households. Okay, this is average occupancy per household. Nice and cool. Now you get to figure out, you can drop the original features if you want to. Probably a good idea so you don't clutter it up on your next heat map. Okay, so you're left with total rooms, total bedrooms, and population. I want to get rid of those because they are incorporated in the new features you created. Just keep it simple, especially those of you with a lot of features. All right, now it does that. Now I'm going to look at the DF head again, DF encoded head. I'm still working with a data frame named DF_OHE. I need to come across here, think about it. Aha. There's the one hot encoding, and here are the new three new features, but I also dropped total rooms, total bedrooms, population, they're gone. I'm very happy. I might even be thrilled. Hard to say. I have had students in the past say, when I finally got the data set cleaned, I just stood up and applauded myself. I agree, I've done that. Okay, now I want to do the null features, make sure I want to check null again, they're all 0, even the ones I created. All right, now I want to go back in and do another heat map to see what's happening. You remember, you had this one, you had to clean it up, so you came down here. Now you're thinking, okay. But an interesting thing, obviously, median income and median house value, 0.68. Then they've got some of this proximity stuff here. You say, well, you know, let's just watch that a little bit. Then you think, well, maybe I should do something with that 0.68. Same code, by the way, to run the heat map. All right, average rooms per household, average bedrooms per household are highly correlated. Average rooms, average bedrooms, 0.74. So, you know, we can think about this, but right now, let's look at this one. Okay. So now I think let's drop one. Once again, the simplest. Now, I've dropped average bedrooms per household, so I'm going to do my heat map again. These are looking nice. Okay, only have that left. Median house value is in the hundreds of thousands, orders of magnitude higher than the others. So we're going to scale the median house value, okay, because it's orders of magnitude greater. Run the first 5 rows again. So you come across and you're saying, this looks pretty good. Now, median house value is this, okay, this feature. Let's move it down. What's that? I just standardized. What am I looking at?
Standard deviation.
Huh?
Standard deviation.
Standard deviations, absolutely. I've got a mean. So this particular house is 2 standard deviations greater than the mean. So anytime you do a standardization, mean standard deviation, it's just like a bell curve. Okay. So if this were negative, I'm south of the mean. If this is positive, I'm north of the mean. Okay. Now, everything looks okay. You could standardize housing median age and households, and pretty much everything's kind of roughly close to the orders of magnitude here. I went ahead and saved it. If you run the neural network, I go ahead and standardize every single feature. Just go ahead and do it. It'll help actually it'll help all your algorithms, but it will flat solve your neural network for you. It'll help it, okay? If you run a neural network with these 3, I'm jumping ahead, but if you run a neural network without these standardized here, you're probably going to get some interesting convergence problems. So go ahead and standardize when you see this is in the 10s, this is in the hundreds, everything else is in the 0 to 9 digits. So go ahead and include these 2. But notice what you did here. You have solved your problem cleaning up this data set. Okay, with your data sets, whatever you guys are using, that's it. Keep using it. That clean data set. Go back to the original. Now what do? You've got to save it somehow. So in this particular case, you're going to save this one hot encoded data frame. It's still a CSV, comma separated values. I'm using data path and data file. You guys, however you input the data, your data set, you'll just have the name of your data set, and I just put a -5 behind it, .csv. It could be -2, -3, you can name it Fred. It doesn't matter as long as you use that going forward. Okay? All right. One we're going to be playing with, let's see here. Going forward is a lot more interesting. Okay. Want to run all your cells, of course, we're going to run all, you can run individually if you want. This thing will spin for a while, then it'll tell me to mount the drive, and we'll just proceed. All right, the green checks are coming up. Okay, while it does the rest, we're looking at telecommunications company churn. Okay, churn. you leave the company. Everybody knows about managing churn. All of you churned. All of you off the wireless company too, because you get the sweet deal. Okay, they'd like to minimize that. So you have churn, no churn. Okay, that's your dependent variable or what you're trying to predict. If you look at what we've got here, by now you guys, clearly I don't need this. Okay, categorical. Okay, senior citizen, my group. And you got to do something here. You can't deal with yes, no. Come across. Oops, I got an ellipse right here, which means they're missing features. Then you've got all these features. What are they doing with all these features? They're trying to figure out, what are you trying to predict? Who's going to churn? Who's going to leave? You're not trying to predict people who are going to stay. Okay? You're trying to predict people who might take off and go to another company. So monthly charges, total charges, payment method, and so forth. All right, I've got the ellipse, which means I have extra features. So I come down here and I said, okay, here they are. I'd rather list them, so I put in the DF info, and notice you've got objects, you've got integers, and you've got floats. Look, you got a boatload of objects. Those are categorical variables. You got some cleaning to do. Okay, so you say, let's see here. There's a statistical summary. If of just the numerical features, I commented it out because this is only if your metrics start coming out squirrely and you're starting to think some of my numerical values are getting weird. Here's my size and shape. What am I looking at? 7,000 instances, 21 features. Okay. There are the column names. I'm going to dump customer ID right away. I go ahead and run the DF head to make sure it's gone. Again, if you're pretty sure, you don't have to run a DF head all the time, but I will say it's great to have a backup check. Gives you great confidence going forward. You'll notice I'm trying to do one function per cell block as we go through this to make your debugging a lot easier. Okay, categorical columns. Okay, a bunch of them. You already know what they are, but I went ahead and fat fingered those things in there so you can see. But what I need is, I've got the categorical columns. You've got to have unique values. You need to know what's going on inside the categorical feature. All right? Gender, quite clearly, female, male. Partner, yes, no. Multiple lines, no phone service at all, no or yes. Then internet service, DSL, fiber optic, no, etc. Now you have an idea of what's going on. Payment method, remember every single thing is case sensitive and must be typed in exactly. So in this case, whatever's in between the vertical apostrophes, type it in correctly. Don't just put bank transfer in, it'll kick it because it has to have automatic. So whatever is inside these apostrophes, that's how you put it in. So now you've got the categorical values. You know what's the unique values inside each categorical feature are. So now you know what to work with. Obviously, what are you thinking right here? What are you going to do?
1, 0.
Yeah, you're going to encode. You get to figure this out. You can use all sorts of, ideas. Now, this particular code, what I did, after I fat fingered all this in, when I did this notebook, I realized there's shorter code to do this where you don't have to type in everything. This code block here identifies the categorical features for you. Okay, so as I said, you do not have a Python wizard up here. So I found this later and I went back in and put this code in because I got tired of typing it. Okay, but this will do this for you too. And instead of typing all this, you get to come down here and just say print categorical features and then print their unique values. Okay, so just to let you know. So what have we got? Now I'm going to check for nulls, and I have all zeros. Very happy. I've encoded. I've got no missing values. So it's a nicely organized data set. And so this is your code for identifying null values. And then percentages, of course. Okay, now this is what we're going to do. What I decided to do, by the way, however you guys decide to encode your data sets, it's not wrong as long as you do it. It's not like somebody with a red pen's going to come in there and go, oh, you use direct assignment here instead of one-hot encoding, -1. No, just whatever you decide. So I just winged it, and I said, what we're going to do, we're going to take all these, and we'll just use direct assignment. Okay, now there are a couple ways to do this. For purposes of illustration, I went ahead and took the feature names themselves and I typed all this in. Okay, there are other ways to do it that we'll pick up later, but you'll notice one thing I did, when I got started here, I capitalized gender. And I typed the whole thing in and ran it and it kicked it out. And it was not one of those real easy errors. So I had to go back in there and realize gender was not capitalized, but all the rest of them were. I don't know why. But this is how sensitive it is. Okay, so what I do, female 0, male 1. Okay, replace female with 0, replace male with 1. Partner, no yes, 0, 1, and so forth. What I would do is I would make sure that in every no yes, that I had the no's as zeros, just for consistency. It's really not going to foul you up. You can do it the other way. It will not give you an error. But when you're trying to translate it back when you get the results, you're going to have to end up going back to this to figure out what you did. Okay? By the way, when you do this, don't forget where this is. When you're trying to explain the causes of churn, which we're about to do, you're going to have to go back to this and realize what you assigned. Okay, so for example, multiple lines, no phone service, no, just one line, and yes is more than one line. So 0, 1, 2. By the way, every one of these direct assignments starts with a 0. Mail, check, bank transfer, and so forth. 0, 1, 2, 3. There you have it. Okay, so now, then you're going to have to figure out what are you going to do with the churn variable? Because when you get ready to figure out what you're going to predict, and all of you get to do this, then when you get the data set itself, there's your predictor. Yes or no. Okay, yes means they're leaving or have left. No means they stayed with you. Okay, so that's our dependent variable. I went ahead and assigned it. No and yes. No is 0. If I say no churn, they stay with you. So 0 means they stay with the company. 1 means they may leave. Okay. If you get something like all this stuff, this is data science-y stuff, do not worry. Now, just out of arbitrariness, I figured I would take internet service and do one-hot encoding on it. And just out of curiosity more than anything else. So I did a one-hot encoding. I did not change the name of the data frame. Okay, I did that on purpose for the simple reason that I'm going to go with this data set all the way through all the algorithms. Okay, and it was not necessary to change the name of it in this particular case because I wasn't going back to the original, and I won't do that at all. So what you end up over here, there is your monthly charges, total charges. There's your churn value. Then you have 3 features here replacing internet service. So here's DSL, fiber optic, and no. So it looks contradictory. You don't always have to rename these things, but this just happened to be, it didn't make any, I didn't have the cursive dimensionality because I replaced 1 with 2 more, but I'd already dropped the customer name too. So I was okay on features, number of features. Okay, now I've got to do the heat map. I'm pretty thrilled with what I've got there. It looks pretty good. I come down, I say, yeah, I've got this. Painful. So what have I got? online security, online backup, device protection, tech support, streaming TV, streaming movies. What is this? This is how the world, all these tend to be people who are probably tech savvy, they're streaming, they've got device protection, they've got online security, online backup, and notice, these are very high correlations. Then, here's monthly charges, and total charges, of course, they're highly correlated too. So then you sit there and you go, well, okay, need to do something. By the way, is it possible to leave all this alone and just run your algorithms? Yeah, you'll get distorted values. You don't have to do multi-collinearity. I'd recommend it, but it'll still run. You just won't get, it's not wrong. It's just what you decide to do. Okay, so I want to check before I really get in there and do feature engineering. So I want to print before, this is the columns, and now I want to create two new features. So I'm going to do a security package, online security, online backup, device protection, streaming package, streaming TV, and streaming movies. Now, I did, when I first did this, I have to confess, I thought of these two myself, and then I asked GPT, and that looked pretty good. Don't hesitate. You know, you can literally ask it, am I walking in the wrong direction? It'll tell you. Use it. Okay, everybody okay on it? Use it. You're not cheating. Okay, now, I want to drop and verify. Okay, so I got rid of these 5 features, replaced them with 2. I want to verify this. So here's the before. And then I come down, new features, 0, 1, 2, 3, 4, created, security package, stream package. You have to take this column, move it to here, this column, move it to here, this column goes over here. So I'm sure there's some way in here to align these columns. I wasn't particularly concerned with that. I just want to make sure they were there. So here's my after. Okay, so I've got security package and streaming package 2 replacing 5. Now let's run it again. Security package and streaming package are highly correlated. Okay? Obviously, so are total charges and monthly charges. Okay, so I say I'm going to drop one of these. So I drop streaming. Want to run it again, see what happens. It looks pretty good, even though security package, as you'd expect, is highly correlated with tech support. Now I say, okay, let's run the DF head, see what we got. Oh, it's pretty good. Okay, but I got a little problem. These are orders of magnitude bigger than the rest, so I'm going to standardize them, which I did. And I got the classic Z-scores, okay? Standard deviations. For the first 5, my monthly charge and total charge is below what the mean was. You could look at tenure and do that as well. Again, when you get ready to run your neural network, standardize that too. Okay, so now what you've got, we're going to save this file. Now, as you'll notice, that is just standard. Okay, what we did, we came right through, we entered it, did all the machinations, checked for null values, we encoded, we imputed, and then we standardized. So what I've done, I said, okay, what I want to do is I want to save this data set, and I'm going to make it the new data set with a -2 behind it. And this is the code that you do that. New files, original file, replace CSV with second version .csv. What you're going to end up with is this data set. Okay? Now, when you look at this, we have not taken any instances out of it. So it has 7,034 rows, and it has $18 columns, 18 features. Going forward, I want to run a logistic regression on this thing, which we'll do after we get through the linear regression. You use the -2. You got the original, telecommunications company customer churn.csv. The one with the -2 behind it is what you want to use going forward. You start all your algorithms with that. Okay, you'll have much shorter algorithms than you had doing this. Everybody straight, this is how this works. Okay, California housing lends itself to linear regression, of course. As you can tell, I know y'all are sitting there thinking this is not linear regression, this is multiple regression. It is. But the name of the algorithm, because there's a linear relationship among the features, Python really likes to call this linear regression. Don't let that throw you off. We're doing multiple regression. What data set are we using? California Housing -5. Okay, that's because I saved it back when I did the data cleanup. I used -5 just arbitrarily. Okay, so you read it in. This is the one we just did. Okay, so that's what you're dealing with. Still got the same number of instances. Now I'm down to 11 features. Look for nulls just to back check. You do not need to do this. Okay, all you need to do when you get cranking is I would enter the data set you cleaned, which is yours, and run a DF head on it to check that you brought the correct one in. Check the size to back check what you just did with the first 5 rows, and then don't worry about missing values. Okay, so what's the very first thing you did? I mean, you could do that if you want. If you cleaned it correctly, these will obviously be 0. Okay. All right, so assume that you come in, you say, okay, I'm ready to run an algorithm. All right, you bring in your code libraries. Notice I'm going to bring model selection in so I can split it into training data set and test data set. Here's my linear model. I'm going to import linear regression. I've got to run the metrics, and all of you are familiar with the metrics, mean squared error and R2 squared, R squared. Okay. Let's see. This. Okay, and then import linear model. Yeah. You could, because you've already done it, I could take out these 3 for sure because you've already done your standardization. But don't worry about that. Having more code libraries is better than not having them. Okay. All right, so I come down. First thing you do, you define your independent variables, your dependent variables. We already talked about median house value is going to be what we're predicting. And all of these features here, which I figured in just for fun, I'll show you the shortcut later. Those are all your independent variables. There are 10 of them. If you decide to keyboard it, make sure everything is just like it was up here. Okay, first thing, you have to define this. Your X values and the Y value that you are predicting. Second thing, split your data set. This code right here, you have 2 hyperparameters, test size 0.2, which means you're going to train with 80% of your data and you're going to test with 20%, and random state equals 42, leave the 42 there, it's for reproducibility, don't worry about that. This code you will do every single algorithm, those two blocks. As soon as you get here, then you move into your models. You got linear, you got logistic, decision trees, random forest, support vector machines, k-nearest neighbors. Yeah, okay, those are all the supervised learning we're going to do. And next thing you do, you pull in the model. Okay, linear regression, you've got the code block there, the explanations. There's your model fit. What are you doing with the fit in the model? Training data. Okay, this is your 80%. What does the model do when it goes out and you designate 80? It goes out and it randomly selects. It doesn't just take the first 80%, it just randomly selects out of your whole data set. What does that leave? That leaves the other 20% to test. Okay, you'll get this. Once you run this, it'll give you this. Now, Then you go, y train predict equals your model prediction off the x train. So I'm predicting the dependent variable in the training data set. So it makes price predictions for houses it trained on. Okay. The trained model then makes price prediction for houses it's never seen before. Now I'm into test. Y test and X test. Notice, I don't know why, X is always capitalized, Y is not. Okay, don't get fouled up on that. I have. Okay. Now, what you do is you've just run the regression. Now you have to look and see what your metrics are. Okay. There's your training test mean squared error. Your training and test R squared. So then it comes down here. Let's print them out. Okay. Training mean squared error 41.41. Mean test 0.42. Training R squared 0.59. Test R squared 0.57. You'll look at these two. They're very close in order of magnitude. These two are very close as well. So I'm kind of happy. In other words, suppose that my training R squared was 0.92 and my test R squared was 0.57. I've overfit. I've learned the training data too well. Okay. Same thing with mean squared error. Okay, now it's interesting to look at what we've got going on here. So let's look at the feature names, and we're going to start looking at the coefficients. I want to look and see what's going on with each feature. So I use this code because I want to see how much each feature contributes. All right, what each percentage contributes to the model's prediction. Here's the code you use. It comes right down, and then you have this. All right. Median age, 0.28%. Median income, 11%. You see how it decreases? No, I'm sorry, 11%. Ocean proximity inland contributes 30%. Proximity inland here, island is 44%, and so forth. So it gets kind of interesting when you take a look at this. You say, okay, you figure on age, but if you add up these five, if we had a realtor in the room right now, what would he or she tell you? Location, location, location. Okay, that's about right. Okay. I mean, we have people that move here who did their careers in California but decided to move back to Auburn because they did their undergraduate here. When they sell their house in California, they can buy a neighborhood in Auburn. Okay, so it's location, location, location. And this bears this out. Okay, by the way, why does this sum to more than 100? Because it's the way that they're running the regression. Just something to take a look at. This is extra. Some of you will be running linear regression. Some of you have all numeric values. That means that you're going to be running linear regression, but you're also going to be running random forest regression and support vector regression. So it'll be a little different. Okay, simple linear regression.
May I ask a question?
Yep.
How do you know when to stop? Like when to stop going?
When to stop going?
Yeah.
Okay, as soon as you get your R squared and mean squared error with a linear regression, you're done. Okay. Now with the categorical analyses like logistics and logistic regression and so forth, you'll have all sorts of other metrics. Now, I will say, if you get some really strange metrics, these come out really weird, and I'll show you what normal ones look like. Then you can ask GPT, or if you're really confused, ask me. I've had many weird results. Okay, logistics. Okay. if you have a logistic regression, that means that you have a binary dependent variable. Yes or no, churn or not churn, etc. Okay, so run along. Let's input all our code libraries. Here we go. We're going to do classification here. I've got to import logistic regression. Here are the metrics. Accuracy score, F1, precision, and recall. I'm going to suggest we're going to talk about these, but let's concentrate mainly on accuracy scores for what we're doing in here. Okay, I'll talk to you about F1 score. We're going to definitely put out confusion matrix. Going to get a confusion matrix. We're going to be all over that, and then we'll get started. So what happens is we're doing a logistic regression. We're using the telecommunications churn data set. Notice we pulled it in -2. Okay, if you pull the original in, you pull the wrong one because this is the one you clean. We cleaned and standardized. Okay, we all remember that thing. All right, I just looked up DF info here. The only reason I put it in here was just a quick back check. Probably don't need size either. All right, here we go. We have a lot of features up here. Remember in the previous notebook, I keyboarded everything in. Well, you don't want to do that. I'm looking for churn. That's my dependent variable. So how do I enter all the independent variables? Scroll it up. Okay. My independent variables, capital X. Let's drop churn. And all the rest of them are independent variables. Okay. So it's much quicker. You have to do it the way I did it the last time. And then your dependent variable is little y. Okay. Just makes it a lot faster. As long as you know what your dependent variable is. And I don't want any of you doing multivariate analyses. Okay. If you do, we get to do some extra stuff. Okay. What do we do here? As soon as we've identified the variables, we split them. And you've done the same thing here with your hyperparameter. You're picking test size 0.2. Now, some of you may decide, I'm getting some kind of bizarre answers. I don't think I'd play much with test size. You can you can increase your test size and decrease your training size, but 80-20 turns out to be pretty useful. So I wouldn't play with that. So this will be pretty much what you'll keyboard in all the time. Now, if you're going to do logistic regression, this is the particular hyperparameter. In this case, max number of iterations it'll go through. I put 5,000 in here because I have a lot of features. The default number of iterations is 100. That means that you don't even have max iterations here equals 5,000. You just have nothing. You have an empty parentheses. If you leave that parentheses empty, you'll just do 100 iterations. Okay? All right. So what are we doing here? Let's fit the model. Training data. Logistic regression fit. My prediction is logistic regression. Let's predict it off test. Here's my training data. Here's my test data. Now, going down, you've got to figure out, let's look at the metrics. I'm going to take a look at accuracy, precision, recall, and F1 score, print them out. Okay, here's accuracy, 82, precision 67, recall 60, and F1 score 64. Okay, it'll put it down like this. Now, what you get is, this is the report that kind of matches up with what we're looking at here. But notice what they've done. What's 0?
No churn. No churn.
No churn. Exactly. The people are staying. All right, that's this group. Your precision on the people that are staying is 0.86. This is churn. All right, the precision there is 0.68. Notice as I come across, I've got much higher percentages on precision, recall, and F1 score than for customers that are staying with you than those that are leaving. So clearly I'm predicting the ones who are staying better than I am the ones who are leaving. Notice the support. The ones who are staying, I've got 1,000 in this particular sample, and only 373 are leaving. Okay, that's part of this. But then, of course, down here, you've got the, I wouldn't worry about these weighted averages because it confuses things. But just, we're going to come back to this Monday. But notice what you've got down here. This is your confusion matrix. Okay? Now, you got 4 values. You got true positives, false positives, true positives, false positives, true negative, and false negative. That's probably going to be the most interesting thing you get to deal with. Because every one of the times that you guys run a classification algorithm, you're going to have a confusion matrix, and they're all going to be different, depending on the algorithm, which is perfectly fine. So, I've got 929. If you're on the what do you call it? The diagonal. True positives, true negatives, false positives, false negatives. Okay. What am I trying to predict? I'm trying to predict churn. So it would be interesting to say, okay, you are you're Amazon, and you're trying to predict whether a customer will make a purchase off your recommendation. Okay, so what's a true positive? You're Amazon, you run their recommendation engine.
That you do buy the item and they predicted that you bought the
I
item.
recommend this book to you and you bought it. Okay? True negative.
You recommended they didn't buy it?
Mm-hmm. You're thinking you didn't recommend it and they didn't hunt it up and buy it. Okay? It's false positive.
They bought it and returned it?
Hmm?
They bought it and returned it?
Well, that's interesting. I hadn't thought about that. A false positive means they've recommended to you, you didn't buy it, or they bought it and returned it. That's kind of cool. I hadn't thought about the return part. You're way ahead of me there. That's good. That's good. I hadn't really thought about that. I've been doing this a couple of years. Thank you. Okay, what's a false negative?
They didn't recommend it to you, but you did buy it.
Yeah, you didn't recommend it. They hunted it up anyway, and they keep stats on all this stuff. Okay, you're in my office, and I'm an oncologist, and I'm busy trying to decide if you have cancer. I've got to recommend that give you results. What's a true positive?
Predict that they do have cancer and they do actually have cancer.
Right. True negative.
If they don't, they don't.
You're healthy, you get to go, and that turns out to be the case. False positive.
You tell them they have cancer and they don't actually have cancer.
Right, what's false negative?
Tell them they don't have cancer, but they do actually have cancer.
Which is worse?
That one.
No.
False negative. Which is worse for Amazon? False positive, false negative.
The false positive. False
You lost a sale. What happens in medicine? I tell you, you've got cancer, and so that's bad enough because you just get a heart attack going on. But what do? They get more tests. Get a second opinion, get more tests. Okay, so some of this stuff's pretty serious. The criminal justice system. Okay, so churn's one thing. False positives, false negatives change around. It all depends on your data sets. Some of you are working with divorce in the outreach land, and that's real interesting. Okay, see you Monday.